Hey guys, let's run through a quick example of how to find a centroid, which of course is the center of gravity between 3 points on a plane. By definition, the centroid is the intersection of the medians of a triangle, and the medians of a triangle are those segments which connect a vertex of the triangle to the midpoint of the opposite sides. So, one median could be segment AP in this diagram, and there are two others. I'm going to choose to use BQ, this median. So my goal really is, okay, now that I know the centroid is the intersection of those two medians, if I find the equations of those two medians, then I can solve the system of equations to get the coordinates of x here. So let me kind of take all this stuff off the diagram and get ready to do that. Okay, so let me zoom out a little bit here and kind of go ahead, and I have this all set up to find the plan. To write the equation of median AP, first I have to find the midpoint P. So just a reminder, the midpoint formula, there's one for the x-coordinate, one for the y-coordinate, but it's nothing more than the average of the x-coordinates and the average of the y-coordinates. If you want the formulas, there they are. But basically, I'm going to take point P and point A and substitute, I'm going to find point B and point C and substitute the values to find out the coordinates of P. So in doing so, the x-coordinates are 2 plus a negative 2, or 0, cut in half. And that, of course, is going to equal 0 for the x-coordinate of point P. And then the y-coordinates are going to be negative 5 plus 3, cut in half, which, of course, give me a negative 2 over 2, or negative 1. So the coordinates of point P are 0, negative 1. Now, why did we find that? The whole goal is really so that I can write the equation of AP, and to write the equation of AP, I need to find the slope of AP. So I need 2 points on that line segment or line so that I can find the slope. So I do have my 2 points now that I found P, which happens to be 0, negative 1. I can now use it to go ahead and find the slope. So I'm going to do that, and again, let me just kind of erase my highlighting here. The slope formula, and I'm just going to denote it by the slope of AP for my own records, but it's just y2 minus y1 over x2 minus x1, or rise over run, or however you want to look at it. But the long story short is I got to subtract these y coordinates, so negative 1 minus a negative 4 makes that a plus 4, 0 minus 6 is my denominator, the difference of the x-coordinates. And now I just kind of have to crunch the numbers to get my slope here. That's going to give me a positive 3 on top, a negative 6 on the bottom, so my slope is a negative 1/2. So I'm just going to table that for a second and use it in the next step. Once I know the slope of AP, now I'm one step closer to writing the equation of AP. You could do this a couple different ways. I'm choosing to use point-slope form, mostly just to review that formula for you guys. It's the one that's most forgotten. So I'll just kind of write my point-slope formula here. We just found the slope to be negative 1/2, so I can substitute that, obviously. And now I just have to pick a point that's on that line segment AP to substitute in. I have two choices. I can choose 0, 1 right here, or I can choose 6, negative 4 right here. They're both on line segment AP, so either one of them should give me the same equation in the end. I'm going to choose 0, negative 1, just because the numbers are easier. So again, let me kind of erase my highlighting here, and now let's go ahead and substitute those values. I'm substituting 0, negative 1 into this particular formula. Y minus a negative 1 will make that a plus 1, and then x minus 0 gives me that as my point-slope form. Technically, that could be simplified a little bit. We're going to end up simplifying in the next step, so it's probably not critical that we do it right now, but the most simple form of point-slope form is y plus 1 equals a negative 1/2 x. And now that makes it very easy to do step 4, which is to find the equation of line segment AP in slope-intercept form. All we have to do is subtract 1 from both sides. So in subtracting 1 from both sides, I now have my equation of line segment AP. So that's it. So I'm done with AP. I'm done with the red segment here. Now I'm going to find the equation of BQ, basically by repeating all of these steps and using the green segment and the green points. So let's kind of move down to that. So now I'm going to write the equation of segment BQ. Again, I have to find the midpoint Q first. So same two formulas. The x-coordinate, that is the average of the x-coordinates. And the y-coordinate of the midpoint is the average of the y-coordinates. So we just have to be careful to make sure we're using the correct points. If you look at the endpoints that we're using on the green segment, we're talking about Q being the midpoint of C right there and A right there. So those are the points I have to plug in here. 2 plus 6 cut in half is 4. That's just 8 divided by 2, adding the x-coordinates and cutting them in half. And the y-coordinates, 3 plus a negative 4, cut in half, is some form of negative 1/2. So you might have negative 0.5 there, that's fine. I'm going to flip-flop between fractions and decimals all the way through this problem, mostly because I'm not using a calculator and I'm going to choose the form that kind of suits me at the moment. But you'll probably have decimals for most of these if you have a calculator in your hand. So now that I have point Q's coordinates, now I can substitute that coordinate and those coordinates into the slope formula to find the slope of BQ. So that becomes next on my agenda. So the slope of BQ is just the difference of my y-coordinates again over the difference of my x-coordinates. So you just kind of substitute in as few or as many steps as you need to get your answer. In your papers, of course, you want to show all the details. So the difference in the y-coordinates is a little ugly. Negative 5 minus the negative 1/2. It's really plus 1/2, right? And with the x's, I have negative 2 minus 4. So now I've got this kind of ugly fraction on a fraction thing. So I'm going to do something a little unusual. I'm going to use the 0.5 version of that half, which will give me negative 4.5 or negative 4.5 on top, negative 6 on the bottom. Why did I do that? Mostly so I could do a little mathematical magic. I'm assuming you guys know this little trick, but whenever you get some ugly decimals like this, sometimes you can multiply by a form of 1 to make your life easy. I'm not holding a calculator, so I'm definitely going to do that. I'm going to multiply top and bottom of this fraction right here by 2 over 2. So if I multiply negative 4.5 by 2, I get a negative 9. Multiply, I said by negative 2, excuse me, positive 2. If I multiply negative 6 by a positive 2, I get negative 12. And now that's a nice, easy fraction to reduce to get my slope of 3/4 there. And again, once I have my slope of 3/4, I'm ready to go ahead and use point slope form. So again, if you need the refresher, it's just this. And we did just find our slope to be positive 3/4. So really, I just need to pick a point to substitute in for my x1, y1. I have a choice of 2, obviously. Remember, we're writing the equation of the green line BQ, so I can choose either Q, which has a decimal in there, so I'm not going to do that. Or I could choose B, and that's the one I'll choose just because there are whole numbers. So B is equal to B is the coordinates negative 2, negative 5. So that's going to make this a plus 5 and this a plus 2. And that's my equation in point slope form. So now I need to write that in y-intercept form, which gets a little bit ugly. So I'm just going to do this off to the side where I have some room. But obviously I have to distribute that 3/4, and that'll give me 3/4 x plus, and when I multiply 3/4 times 2, that's going to give me some form of 1.5 or 1.5. I'm going to choose the improper form for now. And now I just have to subtract 5 from both sides. And 1.5 minus 5 is a negative 3.5. And again, just because I don't have a calculator, for me right now, I'm going to stick with that negative 3.5. So that is my equation of the median BQ, the green one right there. Okay, so now that I have the equation of AP with the red line, the equation of BQ, the green line, now I just have to solve the system of equations of these two right here. And that will give me my centroid's coordinates, which I'm calling on my diagram point X. Okay, so I'm going to zoom out and actually set up the system of equations here and solve them in blue for you, because that's the last part of this problem. Let's find the centroid X. So basically what I'm going to do is I'm going to substitute my red equation for Y right there. So that's going to give me negative 1/2 x minus 1 is equal to 3/4 x minus 3.5. So again, just so you can see where that's coming from, the negative 1/2 x minus 1 is coming from my first equation of the median AP. And the 3/4 x minus 3.5, of course, is the second median equation, BQ. So now that I have this, I got it down to one variable, and now I just have to crunch the numbers and solve the equations. You have options here. I'm going to subtract 3/4 from both sides and keep it as a fraction. That's going to give me some form of 1 1/4 or 1.25, whichever form you choose. I'm going to keep it as an improper fraction, mostly because I want to be cool in the next step and multiply by the reciprocal. Adding 1 to both sides gives me negative 2.5 or 2.5. But again, knowing that I'm going to multiply by the reciprocal in the next step, I'm going to write my negative 2.5 as an improper fraction, which happens to be negative 5/2. And at this point, I become too cool for school by solving this equation by multiplying by the reciprocal on both sides. And obviously that cancels, that cancels, that cancels, that cancels. And now I end up with x is equal to, the 5's cancel out, and I think I get a positive 4 over a positive 2, which is 2. So the x-coordinate of my centroid is 2. I'll table that. Once I know that, now I'm ready to substitute, and you have options here. I can put that 2 into this equation right here, or I can put it into this equation right there. I'm going to choose to do the red equation just because it's a little bit more straightforward than the green equation. But it really doesn't matter. We should get the same y value no matter which one we use. So let me get back to my blue pen and zoom in a little bit to make this a little bit more readable. But again, I'm going to choose to substitute into the y equals negative 1/2 x. So if I substitute there, and actually let me not even skip that step. So there's the equation I'm choosing. Now I substitute my x. And when I do the math there, my y-coordinate is going to equal negative 1 minus 1, or a negative 2, which means, ta-da, the center of gravity of this particular triangle is the point 2, comma, negative 2. And that is a wrap. I'm going to zoom out and kind of just have all the work pretty small, but hopefully if you screenshot that and zoom in on your computers or phones, you'll be able to kind of see all the work in one shot. We'll see you tomorrow. Have a good night.